Ibiaho is the area sales manager for Europe and Africa at NOV. Let's put our hands together to receive him.
Thank you for coming. So my name is Marien Ibiaho. I'm the area sales manager for NOV for Europe and Africa for one business line called APL, which is a provider of mooring system for floating facilities, FPSO, FLNG, FSRU, and loading system for transfer of product. So the presentation will focus on two aspects of utilizing potential in shallow water. Most of them are for focus on gas export through FLNG and crude export with a system called the SAL and the SSY. So why shallow water? For many years in Africa, we looked at development through deep water project. Why? Because in deep water assets, the gain and the benefit and the return on investment can be huge. You hit big reservoir, you put big facilities, but you have over 20 life operation of a field, a good return of investment. Some areas is some onshore, a lot of development, like in Nigeria, the onshore Nigeria is huge potential. But we are not looking at shallow water a lot because we had a lot to do with the deep water and shallow water and onshore. But if you see recently, there are places where export of the capability in shallow water have now some technology that helps to focus on what is crucial. It's first the field development cost. More and more now with the rise of project development and infrastructure cost, looking for cost-effective systems, sometimes it's the barrier for FID. You have, if you look at construction of onshore facility to export to crude, availability of the land, long negotiation for acquisition of the land, and all this is time. Time is money for the development of infrastructure. So we're looking for fast-track development project. Now there are new technology that helps do that, not only from NOV, but of course from some of the company providing floating facility on a faster pace than before. Today, you have company that can bring an FLNG on site from the moment that the project is sanctioned in 2 years. So this helps to look at if I'm able to bring an FLNG in 2 years, can I moor it in the area that I am? So we believe that the shallow water is the path for cost-effective export for a lot of area in Africa. So there is a new wave, as I said, of opportunity. Here in this slide, you see some picture that I will present later, but the potential is really between 15 and 70 meter water depth, where you have a lot of area in Africa where there are a good spot for implementation and facility. This is the strategy to avoid complex jetty infrastructure, which are very costly to mobilize. The Senegal with the Gimi FLNG is a very good project that delivered first gas a few weeks ago, but it's a complex jetty that they had to build for the FLNG. If you make an LNG plant, LNG is not new. There are many LNG facilities in the world, but these, again, they are complex, long facility that takes time. Good example, you go in Nigeria, the Train 7 of the Nigeria LNG, still not up running. And at the same time, you have a lot of FLNG that has been already put in place and now producing gas. So what we're looking for is for deploying infrastructure rapidly on a cost-effective approach. Before I go to the two examples that I want to highlight in this session, I want to just touch base a little bit of NOV. So NOV is very wide. When you have some of my colleagues here, when I meet someone and say, I'm NOV, they say, another one of NOV. How many of you guys are here? It's because on a floating facility like this one, there are many areas of the FPSO where we provide equipment. Me, I will focus on the, my division is for the turret and mooring system. It's called APL. So APL, we have two categories of system. One are for production system, so mooring of FPSO, FSOs, FLNG, or FSRU. And the other category is for terminal system, so loading of product from or to tanker to export gas, oil, CO2. We have projects in Denmark, for example, for injection of CO2 through our loading system, the Green Sand project, or ammonia, which is what we believe also for some areas is the future for offshore transfer of ammonia. I will not go in detail of all the technology here, but it's just a slide to show that there is a lot of experience with various systems for production, 23 turret on deepwater FPSO, 3 external turret. We have 21 systems for loading of product deepwater. And a good example here also is the 4 BTL that you see on the slide, which are what the industry used to call the calm buoy, which are buoy for mooring of tanker to transfer product offshore. I will focus on 2 items in this presentation. One for production, so in shallow water, which is called the SSY, the submerged swivel and yoke system, and one for transfer of product in shallow water also, called the SAL, which is a single anchor loading system. As you see, there are also systems with number of reference projects delivered, so technology is relatively new for a lot of people, but it's not new from our point of view for those systems, but we want to share it and develop awareness. So here, it's just a quick slide. For all this system, it's 30 years of system delivered. So we are not an R&D company trying to present the result of a laboratory test, but trying to share that there is life experience of a system installed. So the first one, gas export. Today, everybody in this session, conference, you can see, speak about gas. We want to monetize the gas that we have. In some area, gas was flared for many years, and now they say, we now have some technology to stop flaring and monetize these gas. 2 projects I will share later are using FLNG with one of our systems, the SSY. If we look at the story of FLNG, as I said, LNG is not new in the industry. There are LNG plants all over the world, but the FLNG approach, going offshore with a floating facility to liquefy and export the gas, this is relatively new. Not very new because the first one was in 2014, I think, or with the Indonesia, but today there is 9 FLNG which will be operational at the end of the year. Out of the 9, 4 of them are in Africa. 2 are in deep water, the one in Coral Sol in Mozambique, specific project, and one has a very, from my point of view, non-practical approach with a very complex and expensive jetty in Senegal with a Gimi FLNG. But if we look at some other countries we looked at the approach, there are 2 in Congo and Cameroon, which are in shallow water. What's the range for shallow water? As I said here, it's 15 to 70 meters. It's a system which is fully submerged, so no risk of equipment damaged by the vessel motion. It's enable fluid transfer without need of jetty, but most importantly, we sometimes believe that because it's shallow water, it's not deep offshore, it's not harsh. Of course, it's not harsh environment, but still, you have change of wind direction. You have change of current direction. You have in some area development of subsurface current, but change and bring challenges when you want to operate and transfer project. So 3 of these systems are already in the water. The first one is in Cameroon with the Hilly Episeyo FLNG, operated by Perenco and SNH, exporting the gas associated from the production of oil in Cameroon, but they have been monetizing since 2017 through liquefaction and export of gas. The second one is in Brazil for a gas to power plant. So it's an FSRU moored on the coast with the Nanook FSRU, where in Sergipe, The FSRU is receiving gas from LNG tanker. Regasification is done on the vessel and sent through a pipeline through the onshore plant, power plant on the littoral. And the last one, which is the most recent, it's that we're very proud because I'm from Congo myself. It's the Nguya FLNG, where ENI and SNPC have developed this FLNG project to make Congo joining the club of LNG exporter. Here, normally if I press start, it's just here a small video. Maybe we can slow down the everybody? Yes. So it's a small video to show and highlight the system. As I said, it's completely subsea. It's a yoke system. So you have a turret, which is anchored in a base subsea. And with chains, you have two equipment that we install on the vessel to moor the vessel in this. You have a riser that can transfer the fluid from the subsea pipeline to the vessel. In this video, you see an FSRU because it was initially developed in the wave of FSRU project many years ago. But the system, of course, reverse what you have for an FSRU fluid to have a fluid going from the vessel to the pipeline. It's applicable also for the FLNG from the pipeline to the vessel. Here, you see that the system allows the two vessels, the tanker and the FLNG, to stay connected for ship-to-ship transfer, and with increased reliability, because you here have a system that can weather them completely 360 degrees. So safer operation with change of wind, change of current for it. The second system is for the crude export. Crude export, for many years, we look at the, as I said, the Calm Boy. And Calm Boy was a revolution developed by Shell to load the production to tanker on the area when they have a very nice system to have a tanker to come, moor, and transfer the product in a good environment. We provide Calm Boy. We have four. The four of them, for us, are more in deep water because we believe that in deep water, for this type of transfer, either you need a turret or an external system for the tanker, which is the Calm Boy. But for shallow water, we have another system because we want to remove surface equipment. Why? Because you have a risk of collision in some area, that you have a lot of damage buoy that sank, and then a lot of projects are actually to replace the old buoy that was damaged. You have a lot of splash zone at surface, so you have corrosion that you have for the life of your asset to paint. Lower maintenance, because here it's subsea, so you don't have a winch on the buoy to pull your riser, to pull your system. And this was developed specifically initially in the North Sea harsh environment, but it is something now that we are deploying also in Benin water. So this is a quick slide just to show, as I just highlighted, the difference, why the operator that we speak to are switching in some area from Calm Boy to SAL, is the cost benefit of exposure to surface and equipment damage and maintenance. With a Calm Boy, the installation campaign has a cost also, when with the SAL system here, is one single campaign because there is only one pile to install, and then it's lift. I have a slide for it. It's single installation campaign. And this is not new. Some people say, yeah, but we never heard about SAL. And it's because it was not looked at it, as I said, in shallow water. We were using what worked well, and we all know that we are in an industry that when we know and we use something that's worked very well, we keep it. We want to say, no, it's been there for 20 years, we want the same. But now we have other challenges. Cost, time is now on the table even more than before. So here are the 18 SAL systems that were installed. As I said, most of them are North Sea with UK, Denmark, some in cold water like Canada. But there is one here that we cannot disclose, but which is ongoing in Nigeria to offload production of an FPSO. Here is just another short video to highlight the system. So here what you see, it's a tanker arriving to locations. As you see, there is no buoy at surface to really look for safe approach. Here, what you see, it's just a buoy for VHF communication. So there's no equipment there that you want to damage. So it's an anchor, one single anchor designed to moor the tanker with a system designed and the same operation as a calm buoy. You have one anchor on the calm buoy, one anchor on the system. You have the hose, floating hose, connection here on this one to midship manifold of standard tanker to offload the production, of course, both ways. This is what we believe, at least for project we deliver, has helped to lower the OPEX, the CAPEX, and the maintenance costs. So one other particularity of the system is that they are easy to install because it's only a few item lifting campaign. Here we see the one on the left. It's the base anchor for the sail. So you just lift one base and that will fit into the pile. And pile will be site specific. And the other one on the right is the two lifting campaign, lifting operation of the SSY with the base, the first one, and the second one, the yoke system, which is installed. So shorter time offshore, because you have also some area when fighting to get the installation vessel is already one thing. Readiness of the site for the installation vessel is one thing, and the cost of this installation vessel now, everybody is competing to have them. If you minimize also your installation campaign, you save also in the project FID some particularities. Some picture for it. So here we can see the real footage of the base of the SSY. It's one lift to the subsea part. You have the anchor, the pile. As I said, the pile today is site-specific, so we'll have geotechnical data of the site to define if it's driven pile, suction pile, what type of installation vessel is available in the area to make an installation campaign successful. The picture on your below in the left is the yoke system, and the two last in the right are the sail base. So why we try to push it? As you see, we look at Congo and Cameroon. I'm from Congo, and I was very proud for many years to say Congo, we are oil producer country, and we were focusing on oil. Money was there, and we were flaying the gas. But today, the gas is a value that we want to monetize, and gas infrastructure are not easy, and in the past, they were developed only for large projects that you need to invest a lot for large facility, onshore LNG plant, or a big vessel. The FLNG in Australia, Prelude, it's a fantastic vessel, but it's a massive facility. If you have some quantity, lower capacity, the cost of developing the project was not a good thing. Having a system which is now cost-effective in the balance of the CAPEX that the operator will have to spend and the OPEX, which is one factor that sometimes we forget to look at, because we look sometimes on the cost of the assets and you say, yes, but why you don't do spread more for this vessel, and then I will handle the challenge of the ship-to-ship operation myself. It's because nobody really make the assessment of the 20-year operation of operations. What will be your real cost for all the tug and supply vessel? How will you handle risk for bad weather or change of current schedule in the day? And then when you start to add all of this, you start to realize that the operation and installation costs are also very important and need to be put in the balance. The two Congo of Cameroon and Congo show also that this is something for a switch of mind between we were not using the gas because we were flaring it, and now we want to make money out of it. But how do we do this? We don't have littoral available. The littoral was already with habitation, infrastructure. You can't say, like in Qatar, I have full space. If I want to put a new train of LNG here, I do this. You go in Mozambique, it's a huge project, but the land, it's acquired, it's there, you can do it. But when you don't have the space, when you don't have the money for large infrastructure, going offshore is the approach. Now the constraint when you go offshore, because as I said, LNG is not new, but FLNG is relatively new. So awareness of people who develop projects is something that I think we still lack a link that we want to develop and is part of this presentation. So shallow water was a challenge in the past, and now today it's an opportunity. And there are technology already in place. We believe that there are a lot of other areas where this can be applicable. You look at Nigeria, shallow water potential for it. As I said, Train 7 is taking years to be finalized. You have Ghana, you have Ivory Coast, you have Congo from over prospects, you have Equatorial Guinea, and this is for a big potential that we want and we can support. The other part is for the crude export. I have a lot of friends working in the service industry in Nigeria, and I can tell you the work that operators are doing and the money that they spend to fix and repair damaged calm buoy is massive. You even have projects where after a few years, they have to take it out, bring back to the yard, 6 months, 1 year of refurbishment, put back in shape. Of course, they know it because it's been in the industry for many years. But what we want to remove is all this surface equipment that require a lot of today, at least in shallow water. Deep water is different because in deep water, you need something at 1,500 meter water depth. But for the shallow water, the SAL is also the way forward. As I said, it's also used for, of course, for crude export, but it's also used for other products. It's used also for injection. As I said, it's two ways. So it can be used also for injection from the vessel to subsea. And we actually are delivering now for Denmark INEOS, the Green Sand project, where it is the SAL system applications to, there is no anchor because the vessel will be dynamic positioning using, but the system for transfer and the anchor base, the base, sorry, is the same. So CO2, we also believe that a lot of people say it's a dream, but the offshore transfer of ammonia, this system is also something that we are qualifying this for future transfer. So the last things I want to say is that this is not R&D technology that we share, it's field proven. It's relatively new in the history of LNG, because we've been liquefying gas and exporting LNG for many years, but FLNG is relatively new. And then the system that we are delivering for this is relatively new. We've been delivering a calm buoy for many years, and it's something that a lot of country operators made money with, but there is more money to make if you can reduce a little bit of your cost for the OPEX and the CAPEX of your system. So the idea is to help our client for uptime and projects. So that's it for me today, and if there is any question, please feel free. I'm happy to answer.